Hey everyone, welcome back. So I hope that the previous session is clear and the submission have all went well. In this session, I want to dive a little bit into the technicality, and then I hope to, at the end of the session, help you guys understand the submission requirements and what do we mean by technical detail. So with that being said, let's turn our attention to the screen. Right in front of me, I'm looking at a Colab notebook. So this user interface is called a Colab notebook. And of course, I will share this code with you. So you don't have to figure out line by line. You can take the source code that I provided and you can run it in your own Colab environment. So let me zoom in a little bit. And first things first, you want to have some sort of a API key. As we talked about making API call using SERP API. And in order to do that, you will have to acquire your API key. So let's connect our instance and let's run the first cell. And since I already have my API key on the left-hand side saved in Google Secrets, then I can run this cell directly. But if this is the first time you are running this code, obviously you need to physically save the API key down here by adding as a new secret. So once you have your API key set up, then you can define this following class object. So let's dive into a little bit of a detail of this class object. First things first, there are a couple of packages. These are required packages for this class object to be defined. A class object is a very popular use of Python, especially when it goes to production or when you have sets of code that you want to send up API or anything like that. So the way I do it is I usually start with some sort of comments to define and describe what this class object is doing. For example, here, line 6, I say the class object is called URL validator. And I have this docstring here explaining what this thing is. It's a production-ready URL validation class that evaluates the credibility of a web page. And the factors that we're going to use is listed out here: domain trust, content relevance, fast checking, bias detection, and citation. The common practice to define a class object is to start with init. So line 12, this line you see here, a definition of an init. This means that I am trying to define a couple of variables locally in this class object, and that the class object are based on these variables, and these can be models, API keys, things like that. And they can only be accessed within this class object. If I go to a new cell, obviously it doesn't know what the similarity model is. It doesn't know what the fake news classifier is, and so on and so forth. You get the idea. These are variables defined locally, and it can only be accessed locally from within the class object. So we start with init self, and then the self now has API key, or you can also do similarity model, fake news classifier, sentiment analyzer, things like that. These models are directly queried from Hugging Face. For example, sentence transformer, this code will take this model directly from Hugging Face. So if you want to verify that, what you can do is you can highlight this name of the model, and then you can open up a new tab and then go to Hugging Face. And the link that pops up, this is the model card of that particular model, right? And we talked about this before. This model measures sentence similarity. And if you don't know what that means, not to worry. On the right-hand side, there's an inference provider that gives you this small user interface. So you can interact with it and kind of get a base understanding of how this model works. So you can start adding sentences. So I'm going to say, I love my cats. And then I'm going to compare it to I love pets. Obviously, these two sentences, you can kind of think of that quite similar. And then you can say, today, sunny, which will be a little bit far apart from these two sentences. Oh, I have to make sure to log in. Let's try again. I love my cats. I love pets. Today's sunny. So let's run the compute. And right off the bat, you get the similarity score of the first sentence, I love pets, to be 0.798. And the second sentence, today's sunny, to be 0.122. Now, this should make perfect sense because the sentence, I love pets, it's very similar to the source sentence, which is, I love my cats. So it makes sense that the score for the first sentence is high. The second sentence, today's sunny, well, that's not so much of a relation with the source sentence, right? It has nothing to do with I love my cats. Then the score will be lower. So let's give you a small example or a test case to help you understand the model. And let's go back to the original code. Now you get the idea, right? This similarity model, fake news classifier, sentiment analyzer, they are all just models on Hugging Face that we can pull. And then if you don't understand any of them, you can go on these links and try out all of them. So let me show you the second one, just as another example. So you highlight this model name, and then you go to Hugging Face. And I think the first link should be it. And sometimes it doesn't provide the available token, and that's okay. And if you don't know the inference style or the code or the API to invoke this model, you can go on top right corner, click on use this model, click on transformer, and then there's syntax here to help you invoke the model. And then you can test things out locally in your code, in your Jupyter notebook, in your Colab environment, right? Places like that. You get the idea. So let's go back to our notebook. Here I use pipeline. And as you can see here, it is suggested as the first style, right? The first template. And same goes sentiment analyzer. You get the idea. So once these models are defined in the initializer, you can have access to these models. And then we talk about these methods, right? You want to scrape the page. You want to start building different scores. The domain trust, that may be one score. And then here, what we use is a model from Hugging Face called fake news classifier. We can, of course, have compute similarity score. That's another model that we ran. And then it's going to give us a numerical measure based on that model. We can, of course, check the facts. You get the idea, right? There are different domains, there are different variables, different angles that we use to look at the same problem. So on and so forth, right? Check Google Scholar, we talked about that. And then detect the bias. Well, here it's just a sentiment analyzer. If you have a sentiment too much to one side, then obviously there's a bias. So when all of this is done, in the end, we obviously want to get some sort of rating. Here we have an emoji, that's a star, right? And then we just repeat the number of stars, 2 star, 3 star, 4 star, something like that. The last method, I want to actually generate some sort of a human understandable explanation. And that's what this function is doing here. It is very loosely coded. Obviously, in production, you can have a large language model generate these sentences, and that will be totally okay. Or you can rewrite some of this and that will also be totally okay. For simplicity, in this case, I just use 50 as a cutoff. For example, if domain trust is less than that, then the explanation here says the source has low domain authority, right? You get the idea. And then if the similarity score is less than 50, then maybe this content is not that relevant, right? And so on and so forth. I want to print out a couple of sentences, append them together as this thing called reasons. And then I just join every sentence together so that the reasons now become a big string. And that will be my final explanation. So it's something that's in the nature of natural language. And then everyone can read it and get an understanding of exactly what do you mean by 2-star, right? What do you mean by 3-star? Well, 2-star, 3-star, they refer to one of the combination of these sentences here. So with that being said, you get the idea, right? In the end, we have this final rate URL validity function. We get all of the scores together, and then we put together as this giant dictionary object so that it looks better. So with that being said, now everything is well defined. I know exactly what I'm returning. I know exactly what user can read, and everything is neatly written and stored in a class object. So I can run the cell, and then we're gonna go down, and then we're gonna make an inference. So let me clear this up, and let's wait a minute. Now, once the function up here is defined, let's go down here to run this code. And what's going to happen is it's going to physically go onto Hugging Face to download the model artifact of all of the models, and then it's then going to make an inference, right? So let me take your attention up here. Remember earlier we talked about in the init, we initialize a couple of variables, similarity model, fake news classifier, sentiment analyzer, right? These are models that we downloaded from Hugging Face. And when you run the code, it's going to execute this package, right? Pipeline, things like that. It's going to physically download the model artifact to your computer. So that's why you see these progress bars doing here. And in the end of this output, you'll see something like this. It's a JSON file, there's a raw score, and then you have domain trust, content relevance, fact-checking score, bias, citation, and then end of the day, you get a 47.8, right? So you can probably say this is a little bit biased, not a whole lot of citation, but you get a little bit of a human readable sentence here. So that is the function, and that is the raw function and how it's defined, right? Now, we also talked about doing this in a small user interface so that the user can then understand what it is that you're doing. Because the user may or may not have programmatic access of this function. They may not have a notebook. They may not have Colab, right? They might just only have an internet. They want to go on a browser and they want to interact with your function. So if that is the case, not to worry. We talked about this environment called Streamlit application. Just like that, this is a Streamlit application. And let's go to files. And in the files, you have README. That's just the instruction, so you can ignore that. All of the code is in app.py. So in app.py, that's where you see all of the code. So for example, this class object that we talked about up here, that is going to be in app.py, right? So I can take you to app.py. And then you see that here's the package and here is the class object. And once you have the class object, now you want to invoke this, right? So let's scroll down to see how this inference is designed in the front end, right? So after line 149, starting from line 150, this is the design of the code that affects the user interface, right? So what I mean by that is, let me take you to the app, and then let me open the files as a new tab so that I can walk you through how these lines of code impact the user interface. First line says st.write. This is going to physically print out this string here. Whatever's in the quotation mark, that's going to be what it's printing out. You see a hashtag, level 1 title, app, things like that. That is why we see this first line of statement. And you get the idea, right? st.write, this is my first app, that's the description, just like that. That happens in the second line. And then we want to allow user to type in something. And so the way to do that is to use text area and then to use text input. So immediately people are like, well, what is the difference, right? The difference is the how the text box is presented on the user interface, right? An area is an area, input is just one line, right? That's really the difference. So let's take a look, right? This is the area. The area means it's area, right? It's a draggable box that you can start typing things here. For example, here I said, hey, I've been on an international flight. Can I come back home to hold my 1-month-old newborn? The second line is just an URL, right? It's not like the first line. It's like a paragraph that user enter. So second line is just an URL. Obviously, I want to make it cleaner. So I made a choice that it's a text input, right? People ask me, how do you know to do that? I don't. It's an assumption I'm making just for the sake of demo so that I can show you something different, right? If you're typing a paragraph, something like that, like a search query, you make the box bigger. If just URL, just one line, then you just do one line. That's really the reason there, right? In production, right, in all likelihood, there's gonna be a UI UX expert on the team to say, hey, look, they've done their due diligence. They know that this needs to be a box. They know that this needs to be one line, right? They will tell you that. That's their job. But for the sake of this demo, we just want to prove out the concept that this class object can be invoked, can be called in an app. Then we're good to go, right? So once you define these two input that you allow user to enter something, then you have a button, right? So that's what this line of code is doing on line 158, st.button. So it says if user click on st.button, then it's going to do a little bit of a checking to see if this is even going to be a URL or if there's even a prompt there. If there's nothing there, then obviously let it fail gracefully, right? Say, hey, look, warning, please enter something, right? That's what this sentence is saying. If not, that means both texts have been entered. Then with a spinner, we are going to validate everything. The spinner means that as long as what's underneath the spinner it's still running, the spinner will continue to run, right? So let me show you what that looks like. Here we have things in the first box, things in the second box. So we're good to go. I will click on this. You're gonna see this spinner. That means it's loading, right? So this spinner will continue to spin until this finishes running, just like that. So now you get the idea. Once these two lines of code finish, the spinner will disappear, and then we'll display the results. And we tell people, say, hey, look, we're gonna tell you validation result right now in a subheader, and we're gonna print it out in a JSON file. So st.subheader and st.json. And the reason to do st.json is because in our Colab experiment here, what we return is a dictionary. So we know that it's kosher to have JSON to render this dictionary. And that's how we know that in this final output, I'm printing it out as a JSON file. Now, of course, you can say, hey, look, I don't know anything about this JSON file. I don't like it. I'm just going to extract the star, print it out, and then explain it, right? That's totally fine. You can do that. No problem there. Which means the display of the output of this function, it's essentially completely up to your own decision, right? In production, obviously there's a UI UX person on the team. They will be able to tell you what that look like, right? But in this case, we just want to show people that this thing works. So that's why we're here. And once you finish this, you can then essentially finish the app, right? App.py, that's the entire script. So it's a very straightforward, very simple design of a user interface. And I want to just make sure everyone understands it. This, the content here, combining this portion as well as the previous session. So now that you understood what's going on, the question is, what do you submit, right? What is the requirement that you have to submit? Well, I'm gonna provide a template, but before I do that, I think the most important thing is that you understood what goes inside of this class object, right? So every class object, you ought to be able to have some sort of doc string. Let me type this out here. This is the requirements for submission. And the requirements here is you have to explain it in your own words. Number one is, what is a class object? And then what is a doc string? Also, if you have these two questions answered, I think you are good to go with the initializer of the class object. Then what's happening is the know-how, right? How to define init of a class object. And then the answer here is use def. Make sure it's underscore underscore, right? There's two underscore. Let me do that again. 1, 2. 2 underscore init, 2 underscore. And then you start with a self, right? It has to be that particular syntax. So of course, this one, obviously, I provide the answer to you. And then the next question is, what is a method? Now, of course, in production, we talked about async, right? Wait, things like that. We also talk about decorator. For the sake of this submission, you don't have to go crazy, right? You can just explain what is a method. Obviously, the methods are all these functions that we define down here. So as long as you can explain that or give an example, then that convinced me that you understood this question. The next question is, how do you let functions fail gracefully, right? I'm going to verbally tell you, but I expect you to write it down yourself or using your own words. So the most easy way is to use try except statement, like line 23 and line 28. That's what that means, right? If there's requests that we can make, let's make the request. Let's save it in the response. That's what the try statement is doing here. There's an except, meaning that if something goes wrong with one of these API calls, we let it fail gracefully. We do not fail the entire script, right? So that's a standard way to handle this kind of stuff. So that will be this question here. How do you let functions fail gracefully? And then last but not least, I want you to be aware of the output, right? The return statement. So the last question here, you should answer, what's a standard practice of a return statement? And then we talk about JSON, right? So I expect you to explain what that is. So there you go. Please answer these questions in your own words, and please submit that in a markdown file. You can add the markdown file in a GitHub repository, and then in the submission form, you can then add that GitHub URL inside so that I can go onto your GitHub URL and see these questions. So I think that should be pretty good for this next submission of technical report. Something very simple, right? I don't want anybody to get tricked. This is not meant to trick you. As long as you watch the video, I hope that these concepts should be pretty clear. And if you have more questions, just feel free to drop me an email. Cool, awesome. So thank you for watching, and I'll see you in the next part.